So we talked about the tetrahedral geometry of molecules with a steric number of 4. And just a quick aside on the nomenclature for how to draw things as a chemist in 3 dimensions. Okay. Chemists use this dashed wedge notation. Okay. Basically, if you draw it normally like this, that's in a plane. Okay. So that's in the plane of the paper. But this A to B bond, that's called a wedge, okay, that thick one that I'm circling right now, that is pointing out towards you, okay? So that's coming out of your screen. That's what that's supposed to represent. And this one with the dash, that's going behind you. So this dashed atom in 3 dimensions here, kind of a more 3-dimensional one would be that one. This one's coming out at you. That's the wedge. That's this one, okay? So those are together. And this is the ones that are drawn normally. That's a plane, okay? You don't really have to worry about this for this course. You'll see it if you take future chemistry courses, especially, not Chem 122 too much, but especially any of the organic chemistry courses. You'll be doing this, every day. But just wanted to introduce it to you. You don't need to know it for this course, but when you see me draw that, that's what it means. A wedge, a thick line like that means it's coming out of the board or coming out of the slide, okay? A dash means it's going behind. Okay, so we're gonna continue on past steric number 4, steric number 5. These can occur when you have an expanded octet, okay? So like phosphorus pentachloride. The steric geometry here is called trigonal bipyramidal. Why is that? Well, there's a triangle right here. Again, this is a wedge, so it's coming out towards you. This is a dash, it's going behind you. That's these. That's the triangle, okay? And then it's capped with a pyramid. See, if I draw like this, I can make a pyramid. So that's a pyramid. And there's 2 of these pyramids, one on the bottom. So that's why we say it's trigonal bipyramidal, okay? If you don't have any lone pairs, that is the shape, right? If you don't have any lone pairs for any of these cases, any of the steric numbers, remember the shape, molecular shape is the same as the steric geometry. Okay, but if you do have a lone pair, then you're going to have a different shape, right? It's going to be based on the trigonal bipyramidal geometry, but one of these atoms is going to be gone because it's a lone pair right now. And so it's going to look like this kind of funky shape. We call that a seesaw. Okay. By the way, bond angles here, for the idealized bond angles for a trigonal bipyramid, there's 2 sets of angles, right? It's 90 degrees when you're not in the triangle and 120 degrees when you're in the triangle, okay? And when you have a lone pair, again, a lone pair is going to make these angles less than those idealized angles. So this angle here is going to be something less than 120 degrees. And this angle here, we don't know the exact value, but we can say for certainty that the VSEPR theory predicts it will be less than 90 degrees, less than that ideal angle, okay? If you have 2 lone pairs with the steric geometry of 5, that's going to get you a T-shaped molecule. Hopefully you can kind of see this. Now you've removed 2 from this triangular position, and that ends you up with a T-shaped. Again, it's going to be less than 90 degrees here because of those lone pairs. But ideally, it would be 90 degrees, but it's always going to be less, okay? If you remove all the triangles, well, you're back to linear. And at this point, you're back to linear. This is going to be 180 degrees exactly. Linear is always going to be 180 degrees because which way are you going to distort it? Are you going to bend it this way, right? Or are you going to bend it that way? Well, you're going to bend it equally strong each side because of the lone pairs. And all these lone pairs are going to be pushing equally as hard. So it's going to be 180 degrees exactly, okay? All right. Last one we're going to do is a steric number of 6. Again, this is possible with an expanded octet. This gives you an octahedral steric geometry. Why is it called octahedral? Well, it has 8 faces. okay? It forms an octahedron, but this has 6 things bonded to it, okay? So don't get confused. It's called an octahedral shape. There's just geometry things. You know, you can draw like a shape. A face would be like this. There's 8 of these triangular faces, but that's not too important. This is going to have 90 degrees again. And then you can have different molecular shapes with different lone pairs. Okay, so if you have one lone pair, that means you basically just removed one of the atoms from the bottom of the octahedron. That's going to get you a square pyramidal shape. Hopefully you can see that. There's a square right here, and then there's a pyramid right on top. And so that's going to have a bond angle, again, of less than 90 degrees because of the lone pair pushing at it. Square pyramidal, that's going to be 90 degrees. Exactly. Okay. This is square planar. Sorry. Square planar, that's with 2 lone pairs. Why is it exactly 90 degrees and not less than 90 degrees? Well, again, this one would push down that way. This one would push down that way. And they're going to push equally as hard. And so within this plane here, it's just going to be a perfect square. Okay. So, this is actually surprisingly simple. And if you think that's a lot of information, I understand that it is. But once you can see it in your mind's eye, it's actually very simple. And so, I suggest you practice this in some way. You can go to these links, which have 3D molecules that you can rotate and look at and be able to see. And it's like once you see it, it'll click, and it's really easy. Or you can use gumdrops or marshmallows and toothpicks and make these things pretty easily. I am having you memorize, okay, all of these shapes. That's going to be part on the 3rd exam. You're going to need to be able to come up with these from the Lewis structures that you draw. And I'm not giving it to you because you should be able to, it should be easy to memorize, because it's not actually memorizing most of it. 90% is not memorizing it if you can visualize it. Okay, if you're rote memorizing it, of course it's hard, but if you really understand it, it should be easy. Okay, so if you're having problems with that, please visualize it in some way. Use a model either virtually or physically. All right.